Я теперь спокоен, слушай. О, смотри, Java B, Pol. Символ касания. Это Егору подарили? Да, это я. Так, там, ой, я слушаю это.
Всех надо звать, да? Я там уже в чатике написала. Лера, зовите всех. Сразу после меня. Да, а возьми микрофон у ребят. Что? Кто там на белом стульчике? Модератора. Вот ты. Ты хотела посидеть? Ну, посиди. Стой, подожди. Ну все, 10:01, начинаем. Я вас приветствую на 6-й конференции Java Day. Мы очень рады, что собралось так много людей. Еще, я знаю, многие допивают кофе, пока подтягиваются. Мы немножко вам расскажем организационную информацию. И я это сделаю по-английски, потому что у нас в зале присутствуют гости издалека. So, hi everyone, once again. It's our 6th Java Day, and we are congratulating you on this. If you haven't logged into our Wi-Fi, you can do it right now. And we would appreciate lots of tweets. And if you join our Telegram bot, it's over here. Do it. You'll be able to see all the news, see the schedule, talk to everyone. It's like a Tinder. So it's really cool. And also, I would like to say huge thank you to our partners. Thanks to them, we're all here and we have this conference and we have regular Java meetups. So it's really cool. Thank you very much. You are invited to after party after the conference, and it will be held at Space. And you can take a taxi there with a discount, and you'll see all the information in the Telegram bot. And you're offered a free drink, and the tickets for the free drink you can find in your bags. So enjoy the conference. If you have any questions, schedule or anything else, just find us, organizers and volunteers. They have yellow badges. And enjoy. And I'm giving my word to our partners, Apollon, Alexey and Irina.
Привет. Я буду на русском. Apollon, компания Apollon является подразделением EEC, Apps. И в Минске собирают команду звезд по Java. Поэтому приходите знакомиться со мной.
Да, приходите знакомиться со мной. Я около стендов. Чуть больше всегда расскажу про нашу команду, про нашу компанию. Леша, если что, расскажет какие-то технические детали про наши проекты.
Да, так получилось, что когда мы начинали делать Java Day, я еще не работал в Apollon, но, как видите, они настолько хороши, что теперь я представляю их как партнер компании Apollon. Но не будем отвлекать, поэтому конференцию можно начинать. И кейноутом откроет Yegor Bugayenko. Я думаю, в представлении особом Егор не нуждается. Евангелист ООП. Егор, наверное, ты лучше про себя скажешь сам. Да?
The other way around? Yeah, can you hear me? That's great. I believe that object-oriented programming is a good thing to have. And last year at this conference, I was trying to explain, I also had a talk, and I tried to explain why object-oriented programming, I believe, is in trouble right now. And maybe some of you were here and you remember that. Who was at my talk last year? Oh, just about 15 people. That's great. So today I will try to show you object-oriented programming from a different perspective, from the angle of unit testing. So we will see how unit testing suffer from not so perfect object-oriented programming, which we have in Java in so many libraries and in so many places in our code. But before we start, a little bit of an announcement. Before this conference, I created a game, a Java simple game in GitHub. This is the address in GitHub. It's called Hangman. And I asked everybody who wants to try your skills. Can you put the voice a little bit down because it's too loud, the microphone? Hello? So I asked anybody who wants to, yeah, that's great, who wants to participate to try to refactor this Java code from a really non-object-oriented style to more object-oriented. And I promised that I'm going to give my book for free to the best pull requests. So some people submitted their pull requests, they tried to refactor and tried to improve. You can try it as well. Even though the conference is finished, well, will be finished, you can try it after, and if I like your code, if I like your pull request, I'll give you my book for free. But actually 11 people submitted their pull requests, and this person submitted the best code I've seen so far. So I mean, among these 11 pull requests. So I think it was really interesting. You can take a look at his code. And even though he's not from this conference, he's from Ukraine, so I will give him the book for free. I don't know this guy personally, but the code I liked a lot. A few words about the book, and then we'll start. So I have this book. This is the second volume. I also promised to some attendees of the conference that I'm going to bring my book second volume here, but it didn't arrive. I mean, we didn't have enough. We sold too fast. So that's why the price will be still going to be $20 instead of $40. But for everybody who wants to get it here, I'll make a free shipment. So I'll send it to you for free. So if you want to get it here, I'll send it to you a bit later, but the shipment will be free. That's it about the promotion. Let's start with the unit testing. I was speaking at JEE-Conf in Kiev a few weeks ago about something similar, also about unit testing. And I showed them this slide. Not exactly that one, it was a little bit shorter, now it's longer. So it's a list of anti-patterns which I found for unit testing. So people are saying that we are making so many mistakes in unit testing that they invented names for that. So they invented names for the mistakes we keep making. That's a list of 35 of them. But if you Google, you can find way more, like maybe, I don't know how many, but there are many, many, many of them. So we keep making mistakes in unit testing. And I will show you 3 things now, which I think we can improve. The first one will be obvious. The second one will be kind of controversial. And the third one will be a pure trolling. So get ready for that. Well, that's what we're all about. The first one is called dependencies. So dependencies, this is this thing you'd have to understand. So this is really like basic thing for any Java developer, for any developer, that dependencies are actually evil. So if you have dependencies in your code, then this is evil, if they are unbreakable. Not just dependencies, but unbreakable dependencies. Who understands what I mean by unbreakable dependencies? Not so many, that's good. So I'll give you some new information. So let's take a look at this class. It's called book, and it goes to the database in order to retrieve the title. And who knows what this database.get instance is? It's most probably a singleton, right? Are we Java developers here? All right, so that's a singleton, right? You have to know that. Okay, so this class, in order to get the title from the book, it goes to the database. First it gets the singleton, then it goes to the database through the method fetch. It retrieves some data, and returns the data. So in order to call that, in order to use that class, we create an instance of the book, and then we call .title. Oh, sorry. So we call the book.title, and then we have a title. So actually, this is a dependency. So the database is a dependency for the book. I imagine we have a unit test. Well, is it clear that it's a dependency, right? So the book depends on the database. So without the database, the book cannot work. So the book needs the database to do what the book has to do, to get the title. The book needs the database, that's why it's a dependency. Let's try to create a unit test. So we will need a book test, which is a unit test. Then the book test will instantiate the book, and then the book will go to the database. So that is called a dependency, which is not really what we want to have in our unit test, because we don't want the unit test to go to the real database and try to connect to MySQL or whatever and retrieve the data from there. We want our test to be fast, easy to run, not depending on any foreign resources like database, which may not exist when I'm just running my test on a laptop. So the database is a problem. It's a dependency which needs to be broken, which we need to break the connection to that dependency. If it's unbreakable, if we cannot do that, we call this dependency unbreakable, and that's, if it's unbreakable, then the class book becomes untestable. So if I cannot anyhow prevent the class book to connect to the real database, then I cannot test the book. Well, unless I have a real server running somewhere close to my unit test, which is not really a case in most situations. So we need something else. We need the book to connect to somebody else. We need the book to use something else. What is this something? Who knows what that something means in most cases? Data source, well, but in general, how do you call that data source instead of this data source? It's a mock object, that's right. So, again, we're Java developers, right? Do you write unit tests? Yeah? No? Well, you have to. Maybe I need to roll back and start from that subject. So you need to write unit tests. So when you write unit tests, let's imagine you do that, then you will need to replace the database with some mock object or something, which is called mock object. Something, I put the name something because it's not necessarily a mock. We'll discuss it a little bit later. But something has to be there, not a real database. You don't want a real database because in that case, the testing will be so difficult. So if you cannot do that, if you cannot somehow inform the book that don't go to the real database, go somewhere else, then dependency is called unbreakable. And that's a problem. A big problem. And now there are 4 things which will help you to create unbreakable dependencies. The first thing is the static method will definitely help you to make that mistake. So if you create the class, not a class, but utility class dbutils, and the method will be called fetch, then this is perfectly unbreakable dependency. Nobody can break it. You will not be able to inform the book anyhow to not to go to the database. I think it's obvious, right? Because it's a static method. There's no way to anyhow to inform the book to just don't touch it. It will be unbreakable dependency. Actually, it is breakable in Java. Who knows how to break it? Power mock, that's right. Thanks for that. So you are Java developers. So the power mock is a library which will help you to break that dependency. But you know, it's a funny story. I met this guy who's a creator of this library, and I met him a few months ago at the conference in Sweden. He came to me after my talk about unit testing. I didn't know him. And he said, we started to discuss something which I was talking about. And he said, well, and I asked him, who are you? And he said, I'm a developer of some library for unit testing. And I said, like, what library? And he's like, power mock. And I'm like, really? Wow, that's like nice to meet you. And he's, yeah, I'm not really proud of it. So I'm not really proud of creating that because, you know, not so many people, there are many people saying that this is not a really good thing to use power mock. I think you also understand that power mock can and may be your last resort. So you should not design your tests with power mock all the time because that will create a total mess. Why? Try to Google it. But that's just a tool which you sometimes may use when the dependency is really unbreakable, and that static method is somewhere in the third-party library. So it's somewhere where you cannot touch it anyhow. But if it's your code, don't make it static. So static method is the first problem. Don't use it, ever. It will not help you in unit testing. The second problem is global variables. In Java, we don't have global variables. What do we have in Java instead of global variables? Singletons, that's right. So Java didn't have that, that's why they invented that. They started with, it's going to be an object-oriented language with no global variables, but then, oh, we don't have global variables, how about we create singletons? So it's a mistake in the first place, but if you have the singleton, then you have a global variable, which in this case is also not so easy to break. It's breakable now, but not so, not that easy. I'll show you the code, which I show sometimes on the programmer's interview when I hire programmers, and I ask this question. I'll ask it again, and let's see what you answer. On the left side, you see the utility class, which is doing what it's doing. So it's going to the database and fetching the data. On the right side, you see the singleton, which is doing exactly the same. So there is no functionality difference between these two pieces of code. The left one is a static method. The right one is a singleton. So the method fetch is not static here, but it is static on the left. What's the difference? Why did we invent singletons? Why do we need a singleton if we can use a static method? We'll have exactly the same functionality. It will be exactly the same instance if you have the static method. It will work exactly the same, but singleton is a little bit better. So my question is why? That's a question I ask programmers. So why would you use a singleton if you can do exactly the same with a static method? It's close, but can you give a full answer? So why exactly the singleton? What? The class field. No, but the class is using singleton. Look, there is no dependency. So the class is doing database.getInstance. No, but but in that case, it's not going to be in a singleton anymore. So the idea of a singleton is that it's something which the book connects to. We don't give it to the book goes to the singleton. So it's kind of, so if that would be a normal class, we just give it to the book, right? Like a normal parameter. And then the book will use the database. But it's not going to be a singleton anymore. So the idea of a singleton is to give access to all classes around to come to me and ask my instance. Yeah, but in this case, we'll refactor the class book. That's right, yeah. But if we don't touch the book, the right answer here, I see you don't know the answer, but the right answer is that for the singleton, we have an option to introduce one more method, which is called setInstance. So with the static method, it's static method, the book will always connect to the fetch method, and there will be no option to break this dependency. The singleton makes it breakable because of the setInstance method. So besides the getInstance, I will be able to introduce setInstance, and in this case, the singleton becomes a dependency which I can break. So before I talk to the book, I talk to the singleton and say setInstance, and I provide the mock there. And then the book will connect to the singleton and talk to my mock. That's how it's going to work. So this is the only, in my opinion, I don't see any other reason why we would need a singleton instead of just using utility classes. So that's the second problem, the second method in instrument how you can make this dependencies unbreakable, by introducing singletons. So every time you have a singleton, you're introducing a problem. You're making yourself a problem for the future for unit testing. You will be able to fix that by using this setInstance. But that will take some coding time. Problem number three is actually using the new operator inside your method. So every time in the method you say new, you are creating the code which will be difficult to unit test. Because in this case, inside my method title, I'm creating an instance of the database. And if I create a book and I try to test it, then during my test, this instance will also be created. So that's a dependency. I depend on the database, and it's breakable but difficult. Well, now it's unbreakable if you look at the code this way, but I can make it breakable by using dependency injection. You know what dependency injection is? I can make it a parameter. So now I don't use, as you can see, the operator new. I moved it from the method to the constructor. So every time you see the method new inside every time you see the operator new inside your methods, that's a red signal for you that you're doing something not really right. It's better to move the new operator to constructors. If the new stays in the constructor, then you're using dependency injection, and then it's easy to break this dependency. It's easy to inject the mock into the book before using it. And number 4 is interfaces. If you don't have interfaces, you will have some problems with breaking the dependency, with breaking connections with your dependencies, because if you have just a class, for example, I create, let's say I have a book and then I have the dependency injection, everything is more or less clean, so the book expects the database to come in, and then I'm trying to provide not real database, so some fake database, mock database, whatever. So I'm trying to provide some other object. And if this not real database cannot say it implements database, then it's going to be a problem for mocking and for everything. So if you are expecting the database to be a class, not an interface, it's not really good. So it's better the interface to make it's better to make database an interface, not a class. So then you will have a database as an interface, and then a class real database, and then not real database. This is called polymorphism in object-oriented programming. This is what object-oriented programming is all about. So we need this polymorphism for unit testing. So we need to expect just a database, and whoever behaves like a database will work for us. That will make testing easy. So every time you don't see the override keyword, override annotation in your public method, you're doing something a little bit wrong. So just a sign for you. So every time you write a method which doesn't have override and it's a public method, you're going off the road from object-oriented programming. You're not helping yourself. So to summarize, my first point. So what is evil? Static methods. That's the evilest part. That will help you to make unbreakable dependencies. Second one, singletons. Don't use them ever. Try to avoid them. Use dependency injection. New operator inside your method. It's also no good. Don't do that. And interface-less classes. That's 4 things. They must be obvious for you. This is just obvious thing which I'm just summarizing. Is it still? We're in agreement, right? We have to be, because this is basic. Okay, let me drink a little bit. Because now it's going to be more difficult. How about this? So I'm going to say that mocking actually is evil, even though we need it. But I'm going to say ad hoc mocking is evil. Ad hoc meaning that mocking done here and now for the purpose of this particular unit test. So I'm going to actually say that the using of mocking frameworks is a bad thing. So Mockito, what others are? There must be some other, well, JMock, right? Mockito, EasyMock, JMock, Mockito. Well, I think everybody, who's using Mockito? Yeah, I think everybody. Who's not using any mocking frameworks? There must be some hands raised. Okay, 1, 2, 3, 4. Okay, all right. So I'm saying that mocking, ad hoc mocking is evil. And here it's kind of controversial, but listen me up. Look at this unit test. It is using Mockito, so I'm still with the same example with the book. So look at the last line. The last one says, assert that the book title equals to UML distilled. Who read the book UML distilled? Okay, you have to read it. It's a really good book by Martin Fowler about UML. So we need to know UML if we are Java programmers. It's not a big book. It explains UML in really high level, simple words, and it will definitely help. So check it out. So UML distilled. So we are trying to assert, we're calling book.title, and then we just do, and then go one line up, we're creating the book and we're providing the databases as a dependency for the book. And then a few lines more up, we need to create that database, that fake database, not a real database. We don't want to go to MySQL, so we're creating it. How we're doing that? We're using the function mock. It's a static method from Mockito. So this mock and then database.class will create something which looks like a database. And then the next line we say return UML distilled when somebody connects to this database and says fetch and then this whole SQL request. What's the problem with that is that this is the simple example. This is just a really primitive example. In reality, I found this code in one of my production classes. Yeah, it's good you don't see it, or you do see it. So it's real, it's production code in commercial project. This one is mocking. So I'm preparing something which will actually work later. So I'm building a mock object. If you come closer, you will see, I don't see it here, you will see many when. So I'm building not just one object, but a collection of objects. So I'm preparing like a network of objects, which will be ready for that simple algorithm. So what really happens here, it's a huge mistake we're making here, and I'll explain why. Not just because the code is so long and absolutely unmaintainable. So I think I wrote that code, but I'm not sure, but a few programmers. I think I made some part of that. But if you ask me right now and say, you know, it doesn't work for some reason, this unit test doesn't work, just fix it. How about in 15 minutes? I have no idea where to start from, because I need probably to throw this whole code away and start from scratch. I cannot understand, it's really difficult will be to understand how these objects are connected to each other. And this is just a simple example which I found in 5 minutes of going through one of my production projects. So what happens here, it's not, and this is not the biggest problem, not the complexity. The biggest problem is this, we have let's imagine what's happening. We have this book test, and the book test creates the book. And then the book connects to the mock database. The problem is that the book test, while mocking all this, is making assumptions about how the book will talk to the database. The book test is not supposed to know that. The book test doesn't need to have that knowledge. So the database, the book will talk to the database in any possible way. But in order to keep the two things together, in order to make that mock and the database and the book work together, we need to make all these assumptions. So this code actually made a lot of assumptions here, saying that I assume that one of the objects in production will actually connect there, and another one will call this method, and another one will expect that result. So there are tons of assumptions made here, which makes it so difficult to refactor the book and refactor the database. So if I change something in the database tomorrow or in a year, then the test will fail. Because the test assumed, let's take a look at the one test. So the test assumed that this line, that the SQL request, will look exactly like that. That's the assumption we made. And the test works. The test is green. It says, sure, it works, it's clean. But let's see what happens tomorrow. I'm jumping through the slides. One more slide. So the idea of a test, the idea of a unit test, and then I'll show you what happens. The idea of a unit test in general is to be a safety net for us. You know what safety net is, so I found that picture on Wikipedia. So that's a road with cars, and then the safety net is above the road, and then above the safety net there are electricity lines. So the Wikipedia says that the safety net is there in order to protect cars from the cables which may drop if they fix that. So when somebody go up and start to fix the cable, there are cars running behind. And that person will be so afraid of kill somebody that it will be so difficult to fix the cable. So that's why they put the safety net, to make the work of that fixer easier. Because that person will also know, always know, that no matter what happens, if I drop the cable with 1,000 volts, then nobody's going to be dead because the safety net will catch me. The unit testing is exactly the same. We need unit tests in order to catch us when we break something. So when I open the code, this code, when I open this code, yeah, this one. When I open this code and somebody says, fix it as soon as possible, I need to know that if I change something here in this test, I'm not fixing the test, I'm fixing the code which is in this algorithm. So when I'm fixing the algorithm, I know that this test will catch me and say, hey, you just broke something. So that's what the unit test is for, to give me the signal when something is actually to give me two signals. When I change something and it's still alive, the code is still okay, so all the tests are green, it's okay, I have the confidence that I can continue and deploy to production. Or if it gives me the red light and says, no, you just broke one test, I know that I actually broke something. So this is what safety net is for. But look what's happening with the code. So this is our production code. And this is our test. So let's take a look at these two lines. So our test made an assumption about what's happening inside the book. So the test assumed that the SQL request will look exactly like that. But what if I change something in the SQL request? For example, I will make the select in a lowercase. Instead of select with the all capital letters, I will say select in small letters. It's still going to be a valid code. It's still going to work in production. It still will work with the real database, but the test will fail. So the unit test will crash, and it will give me the red signal, which is called false positive. Positive meaning that we found a problem. So the test will say, hey, I found a problem. This is the red light for you. So something is broken. But that's false. It's not problem. Nothing is broken. But I will take a look at the test and wonder why it's giving me the red signal. What will happen later, I will just throw away the test. I'll just say, I don't know why it's red. Let's just disable it. Let's just cancel it. So that's a problem with mocking frameworks. So every time you build that mock objects to test your real objects, you are making assumptions about how they work with database and dependencies. And that assumptions are pure evil. What's the replacement? How to fight with that? Here's the suggestion. You need to use fakes or doubles, so-called. So these are classes. Who knows what it is? These fake classes or doubles for unit testing. I'm teaching you something today. That's good. So, so doubles or fakes, they are classes which you create. They look like production classes. You don't make them inside your unit tests. They are just coming together with real classes, but you can use them in the tests. So let's say you have a database interface, and you have a class which is called real database, or Postgres database, or MySQL database. That's your real class. And together with this class, you ship to your users or to yourself another class which is called fake database. Look at this code. That's how it would look. So this is going to be your book, exactly the same. So it accepts the database as a dependency in there, and then in the unit test we provide not something which we constructed by using mocking frameworks, but we provide a fake database, an object which behaves like a real database. It can be quite complex object. It can be quite complex structure. It's not going to be easy. Maybe sometimes it's not going to be easy to create. So in this case, it will be something which will probably understand SQL, which will probably understand this language. In case of a database, you can use, for example, I'll give you a real example in my practice. So let's say in production, you have the database which is Postgres, but in testing, for the testing, you can use H2, for example, which is an in-memory Java database, which also understands SQL. Of course, there are different dialects or something like that, but for primitive requests, it's possible. So you can create an object which will behave like a normal production database. In one of my libraries, we created we have a library for connecting to GitHub, to the GitHub API. And the GitHub API, they have like maybe 200 different access points. So they have maybe 200 or 100 something different objects which you can query from them. Like give me the information about the user, about the issue, about the pull request, about that line of code, about the file, everything. So we created a library for the Java library to talk to this API. But in testing, during testing, you don't have the real API. You don't have the GitHub available. You don't want your unit test to talk to the GitHub. That's why we created a fake GitHub API. So that's a GitHub API that behaves like an API, it looks like an API, but it just keeps all the data in one XML file. So you come to it and say, create an issue. And it's no problem, it just creates the one line in XML file. You say, create a new repository. It says, yes, this is your new repository. So it's the whole GitHub server inside one XML file. It took some time to create it, definitely, but all our tests are now way simpler. We don't have that long mocking and then the small algorithm. We just say, new fake GitHub. Boom, we have a GitHub server for us. So that's a solution. And that fake database could be quite complex. Like this is an example. Let's say you have new fake database, and then you can make it configurable with title, with another title, with user. So you create it, you can make it fluent interface. It's just an example of how you can make it. A database, an API, for everything. You just make mock classes. So I'm finishing this part. So I'm saying that ad hoc mocking, which is done for the purpose of one unit test, is a bad idea. Every time you use Mockito, think again. You're doing something wrong. if you cannot really create a fake object instead, then maybe the whole design is in trouble. So maybe you need to refactor the design. So instead, use fakes. That was a bit controversial subject. So who disagrees? 1, 2, 3, that's good, okay. Now get ready for something even more controversial. Algorithms are evil. I'm talking about algorithms which exist inside the test method. Maybe. I'm not sure, but I'm just giving you an idea, and we implemented that idea in quite fresh framework. It's on GitHub. We started it literally 10 days ago, and inside that framework, we tried to implement the idea we'll give you right now, and it works. You can look at the code, you can see how it works, and it works. So my point is that traditionally looking, the test method, the way it looks usually, is basically very procedural. So we have a line of instructions, a lineup of statements, which configure something, which do the mocking, you saw that before, which prepare something, and then in the end, we have an assert, or maybe a number of asserts, or maybe some verify statements. And this is what's wrong, because it's procedural, it's not really object-oriented. If you would see that code in the real code, not in unit test, I would say definitely that's procedural, you're doing something very wrong. But in unit tests, the idea is that maybe in the unit test as well it's wrong. Maybe we shouldn't have that flat line of statements. We need to have something more structured and more object-oriented. Who knows about that framework? You definitely must know that, and you must use it. And then another question, who knows what the name is coming from, what the name means? You probably have heard my talk before, no? Yeah, it's anagram. It's called anagram. So that's just the replacement of letters. So matchers, if you replace letters, put them in different positions, you will get Hamcrest. So there's no meaning in this word. They just made it up. Anyway, it's a good library which helps you, which provides you so-called matchers for your unit tests, which you definitely have to use. That will make. I don't even need to explain why they're so good. They will help your tests easier to understand. Your logs are cleaner. Everything will be better. So try to use it. But I want to put a little bit more stress into it and suggest something more extreme. My suggestion is that a test method must have nothing but a single statement assert that. Nothing else. So nothing should happen before. You just have one method which says assert that, and then one part, another part, and you're done. If you can't do that, then your code is object-oriented. If you can't do that, then your tests are object-oriented. If you can't do that, then the maintainability and readability of your tests will be way higher than the code we've seen before, with the long mocking and then small algorithm. Let me explain. So first of all, I want to say that this is how I would suggest to understand the text assert that. So look at the code on the top. It says assert that book has title UML distilled. So assert that is a static method from Hamcrest, and has title is the matcher which I created. Well, it's my matcher. It's not coming from Hamcrest, but Hamcrest has something else. So I would suggest to read this text as the line below, that we assert that the book behaves as if it has a title. And if you can read it that way, you can create, because some people traditionally use this assert more procedural, like assert that book equals, or so they think that these matchers are procedures. So has title, in my opinion, has title is more like an object. So it says like, you have a book and then I have something which looks like a book that has a title. And then we compare them. So the first part of assert that is a block of, this is an object. And then the second part is another object which can be compared to the first one. And if you think like that, you will read this code. Assert that, the first part is the book. The second part is the composite matcher. Has URL, has path, contains string equal to. And that's how you would read it. We assert that The book behaves as if it has a URL that behaves as if it has a path that behaves as if it contains a string that behaves as if it is equal to that string. So this is like hierarchical composition of statements about an object you have on top. So you go deeper and deeper, you kind of traverse the object and make statements about the behavior you extract from the object. And it is possible. I mean, let me show you the code from the library I mentioned, from the Cactus library. So this is one of the unit tests. So we have, it's not so important what it does, but on the first part we have, actually there's 3 parts. The first line is the text, which will be in the log if the test fails. So in the log, I will see that line, can't read bytes from a class path resource. And then the second part is actually the object which I'm testing. And the object is created as a one solid block. No setters, no mutability, no manipulation with the object, no imperative manipulations with it. It's just one solid piece of something which is created in just one constructor, just as the way it is in object-oriented programming. Just a composition. We just build an object and get it ready to work. And then we create another object which is ready to accept that big one and say, do you look like me? Do you behave like me? That's an example. Another example. That example is a little bit more complicated because it has this lambda in here, and but it demonstrates how we can test side effect. I'm not sure you need that explanation, but I had many questions on the JE-conf. I presented that idea there as well, and there are many questions in the room like how can you do side effect testing? So if you will have that questions as well, I'll show you that slide, but maybe you will not. I have to finish, I think, so here's the reason. So why do we need that? Why do we need that matchers? The first is that, yeah, some reason it starts from the bottom. So first of all, your unit test methods will be shorter. If you just say to yourself that all I can have is just one assert that, you just technically cannot make them longer. You cannot create a long unit test. You will always have to somehow find a way to put some duplicated functionality somewhere. You will find a way how to make an object constructible from just a constructor instead of setters and initializers, which are evil in object-oriented programming. So you will find a way how to optimize your code. The second one, that your objects will be immutable. That's kind of, they go in line, the previous statement and this one goes along, because the objects will be immutable because there will be no place for setters. You will not be able to do what I did before, like new book and then set title, set, and then assert. There will be no setters because you are not allowed to have that lines. So your unit tests will affect the code, will tell the code, don't be immutable, don't be, don't be not object-oriented. Be more clear and be easier to test. Be easier to use you as a whole thing instead of something more imperative. And of course, the last thing I wanted to say is that you will be able to share that matchers. So matchers are objects which are shareable. You can use them in many places and many tests. And one last point is that I think that the good Java library, providing classes and interfaces has to provide matchers together with them. So in our case, in this Cactus library, you provide a number of objects which you can use for read file, write file, convert text, sort an array, that kind of things. And for all of them, we provide matchers. So when you're going to use our stuff in your code, you will use them and you will use ready-to-go matchers. So every time you create a code, you create an interface, think how people will test that stuff and give them matchers. According to the Hamcrash specification, just give them matchers. They will be really glad to use them because they will make your code way easier. So that's it. I am done. Let me show you the final slide. So who is really interested in object-oriented programming? This is again the promotion. I have an award, a contest for open source projects. My personal contest. I'm doing it for the 3rd year now. 2 years we did that already. So you can submit your project there. Just fill the form. I'll give you the link right now. So just fill the form. If you have a project and you think that you designed that project in an object-oriented way and you like how you design it and how you maintain that project, just submit it to me In November, I review everybody who submitted that. I review all projects, and I give $4,000 for the best one. So I did that for 2 years already. So one person was from Russia, another 2 people last year, they got 2,000 and 2,000 each because they were winners together, and one from America, another one from Europe. I don't remember the country. So you can make that money as well. Just design the project in object. I don't care what the project is about. I don't care how popular it is. I don't care what it does. I don't care how many users you have. All I care about is the quality of your code and how you maintain it. It must be in GitHub, it must be open source, it must be more or less long, over 5,000 lines of code, and preferably it could be in any language, but it must be object-oriented. So that's the summary. So if you're interested, submit it, that's the link. You can make some money. Thank you very much, I'm done.
So, thank you, Yegor, for a great keynote. And just to be honest, I want to leave to rewrite my unit tests, but I should be here. So we have some times, about several minutes. So if you have questions, please shout out, and I will give you a microphone.
Make it easy, because we don't have too much time.
Just 2 minutes.
Hello, I'm here. Thank you for all the stuff you said. I want to ask how much time you spent on writing that matchers versus using Mockito. So I think it should be a bit more time.
Yeah, definitely. That's a good question. So the question is how much time I spend, how can we compare the time we spend on creating matchers versus using Mockito just when we need some mocks. So definitely to create a matcher, we need more time, more thinking power, more brain power, because it's a task. Because when you create a matcher, you need to think for the future. Let me show you the matcher I created a week ago. So if you look at this, you can see function as matcher, func as matcher. This is the one I created myself. Here you go. This one. So this is func as matcher, accepts a lambda, accepts a function here, which does whatever it does, and it behaves like a matcher. So I created it for the purpose of testing functions and something else. I spent, I don't know, maybe half an hour to create that. Maybe it would be definitely easier and faster here just to assert and use something else. But the time I invest into each matcher it's a time I invest actually to the project, because this code will be reused and reused and reused. And this matcher as well we created. Text has string. So this one is bytes as text. So the type of this object is text. Text is our type. So, and then we have a matcher which called text has string. So here I provide a matcher for the string. So what this code does, text has string, it just extracts the string from here and matches it with this matcher. That's all it does. But I wrote the whole matcher for it, the whole class. But every time now I can reuse it and reuse it and reuse it. So I think it's a great investment. So definitely I spend more time for it.
Probably yes, but as far as I understand, you need to write your own matchers for all the units under test.
Yeah, definitely.
So it's, I think it's much...
For all interfaces.
For all
interfaces.
Yes.
Because look at this. This is bytes as text. We have so many classes which as text. So they're all text, but they all implement interface. This guy accepts just any text. So we have in our library, we have 5 interfaces and about now 40 classes. So we have 3 matchers. 5 interfaces, 3 matchers, 40 classes. That's our balance.
Well, maybe it works better for some framework. I'm not sure it should. I'm not sure it will work
for production,
well.
For the library, for the application.
For business code.
For business application, definitely you will have less needs for that. I agree with that. But still, in any business application, you can find some places which you reuse here and there. So sometimes, so definitely don't need to write matchers for all class you have in mind. Definitely not. But this is a good comment. So definitely, if you're designing a library, matchers is a must. You have to provide them. But if it's just an application, then most probably keep the balance. So definitely don't create matchers just for fun, just because you want to create matchers. No. Because of course, every matcher is some investment into, you need a class, you need to test it as well, you need to make sure it works. And if the matcher doesn't work, all unit tests will fail, you know. So that's a good comment.
Okay,
yeah.
Thank you.
Yeah. I think we have to wrap it up, right? Because
One question.
One question,
Okay.
all right.
Hi, thank you for the presentation. So my question is, I personally don't use mock tests. So we have chosen to use integrational tests. So because it fulfills all your requirements you've told us today. And what do you think about integrational tests?
Well, that's a good question, that integration. Some people say that integration tests are, that unit tests are just waste. I've seen that article, and that it's just garbage, so you don't need to create unit tests. All you need is integration tests. You know the difference, right? So an integration test, there will be no mocking of the database. It will be a real database, not a real one, but we'll start it probably in some Docker container, and then fulfill it with some test data, and then we start our Java application. It will connect to more or less real database, and it will become more or less an integration test. And the bigger is environment, the closer it is to our production code, the better. That's the philosophy of integration testing. So you need to create the environment which really resembles and looks like your production library. Preferably use some Docker container which starts everything. It starts Apache, it starts Postgres, it starts maybe even some load balancer inside, so everything. And then you test your codes through some HTTP calls, for example, using some Cucumber or some other library which behaves like a real user. That's a good idea, that's a good thinking, and I totally with it. So I agree with that. I definitely agree that we need that integration tests, and they will definitely help us to see the picture on a bigger scale. You've seen probably the jokes on the internet where there's a door and there's a lock, and the lock closes like that. So they're trying to lock the door, and then so they shift the lock or something, or close with the key, and then the door opens like that. So they thought that the door opens like that, and they close it, but the door opens like that. So that's a good example of lack of integration testing. So the lock works, and that part of the door works. So it can shift here and there. It works. We tested it with the unit test, and the lock works with the unit test, but together they don't work. So they don't really behave like we want. So that's a lack of integration testing. So we definitely need integration testing, but I think that unit testing we need for development. You cannot develop effectively if all you have is a full running Docker container which tests everything, because it will be just slow. The unit tests are very fast, so you can test that lock in like half a second. You just click, you change a little bit, you run, you test, you see the result. Again, you change something, you run, you see the result. And then after you made manipulations, then you run the full integration test, and it will show you like, you know what, you just made a big mistake, you big integration mistake. But these two tests they're separate. They don't exclude each other. They have to go in parallel. I think so. So unit testing is for developers, it's for development. It's just an instrument to help you develop faster. And unit testing, and integration testing is for making sure your system is stable. So I would not replace one with another. Definitely they need to go together. I believe so. And in Maven, for example, we have two separate plugins for that. We have Surefire and we have Fail-Safe. So Surefire is for unit testing and Fail-Safe is for integration testing. They just in parallel. You just name them differently, you place them in different folders maybe, or give them different names, and then you just test them on even in different Maven phases. So the unit testing goes fast right after the compilation. So you compile, you package it, you don't even package, you just compile your classes and then you run unit tests. But integration, you have to start the environment first, then you run integration, then you shut down the environment. So it's a long process, which in most cases you're not going to run if the application is big. So that's it. Thank you very much. We're wrapping it up. Thanks.
So thank you, Yegor, again.